Welcome to the video tutorial for Unit 5, pages 6, 7, and 8. Today in class we are learning balancing. Every teacher teaches it just a hair different. Every student's going to find different ways that work a little bit better for them. But for my classes, at least in the home class, we require you to show work like this. So I already got it started. I cut the problem in half and I wrote down what I have. I have sodium and oxygen, and I write it down on the same side. I have sodium and oxygen. Okay. Now you count atoms. Right now, I don't have any numbers shown, which means I have 1 sodium and O2 right there. It means I have 2 oxygen. On my product side, I have 2 sodiums and 1 oxygen. So I taught my class to balance from the top down, but always leave oxygen for the last. Okay. So sodium, I've got 1 sodium on my reactant side. All we can change are the big numbers out front, called the coefficients. So all I can do is multiply to make these numbers the same. So I can't make 2 any smaller. To make 1 into a 2, we're going to go like that. 1 times 2 equals 2. Now a lot of students were just showing their work and then calling it done. In order to get this correct, you have to show the work up here, because now it's 1 sodium times 2 sodium up top. Okay, so I have 2 sodium and 2 sodium. Those are balanced. Then down below I have 2 oxygen and 1 oxygen. Okay, so all I can do down here is multiply it by 2 equals 2. In order to multiply oxygen by 2, like I did in my work, I have to put the 2 here. And now it's 2 times 1, 2 oxygen. But there's an unintended consequence of that, is the 2, the coefficient out front, distributes to everything, which means I now have 2 times 2, 4 sodium. Okay. So in trying to balance oxygen, I unbalanced sodium, and that just happened. So I'm going to scratch out my work, what I had done before for sodium, and start over. I should be doing this in pencil, but pen it is. So instead, if I hadn't done anything to this problem, remember we had 1 sodium. So if I want to turn a 1 into a 4, I would say 1 times 4 equals 4. I can make that a 4 now. So now I have 1 times 4, 4 sodium, 2 times 2, 4 sodium, and then 1 times 2, 2 oxygen, and 2 times 1, 2 oxygen. So I'm balanced. 4 and 4 on the bottom, 2 and 2 on the bottom, which means I'm going to put a 1 in the blank. So the ratio of these coefficients, or the molar ratio, is 4 to 1 to 2, like that. 4 to 1 to 2. And now it's balanced. So let's take a look down here for number 6. Okay, on number 6, I already started my work. We have chromium, nitrate, sodium, and phosphates. Chromium, nitrate, sodium, and phosphate. Now, you'll notice it's not written in the same order on the product side up here, but I'm going to copy it in the same order. That way I can compare really easily, like this. I'm able to keep my NO3 together because it's in parentheses on both sides. So my polyatomics didn't change, so I can balance it as 1. Instead of balancing chromium, nitrogen, oxygen in 2 places, sodium, and phosphorus, we can just keep our polyatomics together when they're on different sides of the equation. As long as they don't change, we can balance them as a unit. So I'm going to count how many I have to start with. I have 1 chromium here because there's no number. I have 2 after the parentheses, which means I have 2 nitrates. I have 3 sodium, and there's no number here after phosphates, which means I only have 1. Okay. Let me see if I can get that to show up a little bit better. I'm trying to write in pencil now. Chromium, on this side, I have 3 of them. On my product side, I have 1 nitrate over here because there's no number there. For sodium, there's no number, so that means 1. And for phosphates, I have 2. So starting at the top and working our way down, nothing is balanced yet. Yikesy, right? Okay. So chromium, if I've got 3 on my product side, in order to get 3 over here, I have to say times 3 equals 3, which means to multiply chromium by 3 on the problem, I put a 3 in the coefficient. Now that 3 goes to chromium, it also distributes everything after it, which is nitrate. So this is 2 times 3, 6 nitrate now. So balancing from the top down, my 3's are balanced up top, my chromiums. My nitrate has 6 on the reactant side. So on the product side, I'm going to multiply it by 6. Okay. So I'm going to put the number I'm multiplying by right there. So that gives me 6 times 1, 6 nitrate. But it also gives me 6 times 1, 6 sodium. Okay, now my product side is the bigger number, so I need to change my reactant side. It's a 3, so to turn it into a 6, I multiply it by 2. The 2 comes out front. That's 2 times 3, 6 sodium. But it's also 2 times 1, 2 phosphate, which, hey look, that's what I wanted anyway. So I've got 3 chromium, 6 nitrate, 6 nitrate, 6 sodium, 2 phosphate, 2 phosphate. So I'm balanced. 3, 2, 6, and if it's blank, it's a 1. So this is a 3 to 2 to 6 to 1 ratio. Okay, that's what you're doing on page 6. You have to show work on these. Now, number 8. What kind of reaction is it? We've got a carbohydrate plus oxygen yields carbon dioxide and water. That is a CHO reaction, which means it's combustion. And combustion reactions get balanced just a little bit differently. Okay? So what I'm going to do is cut my problem in half and show my work. CHO. CHO. Now for CHO reactions, we balance them in CHO order. C first, then H, then O. So count atoms. 5, 10, 2. I've got 1 carbon here, 2 hydrogen, and I told my students to skip oxygen on the product side. Just skip it for a little bit. We'll worry about oxygen later. Okay. The first thing you have to do for combustion is balance the carbon. So, because my number is bigger over here, I need to change this one. My product side, I'm going to go times 5 equals 5. Now I've got 5 and 5, so I'll put that 5 here. Now that 5 changes the carbon. It also changes the oxygen, but we're going to ignore oxygens here for a little bit on CHO reactions. We're going to worry about it later. So balance my carbon. Next I'm going to balance my hydrogen. H2O, to make the 2 into a 10 like my reactant side, multiply it by 5 as well. Okay. Now I've got 2 times 5, 10 hydrogen. So my carbons are balanced, my hydrogens are balanced. Excuse me. Now I'm going to balance my oxygens no matter what. Now combustion reactions are a little bit difficult because I've got oxygen in 2 different spots in the products. So I've got it here. So 5 times 2, that's 10 oxygen right here. Plus, I've got 1 oxygen times 5, 5. So total, I have 15 oxygen. If you didn't follow that reasoning, pause, rewind, figure that out. I've got 10 oxygen here. I've got 5 oxygen here. So total on my product side, I have 15. So for CHO reactions, we told you in class, in our notes, to balance the carbon, balance the hydrogen, and then balance the oxygen no matter what. So I'm going to balance this oxygen. I'm going to make this into a 15, even though I would have to multiply it by 7.5 to do that. $7.50 plus $7.50 equals $15. And now I'm balanced. But I'm not allowed to do that for real, right? This balances it, sure, but I'm not allowed to have decimals. I need whole numbers. So to get rid of a half, you multiply it by 2. And so if we change one of these balance coefficients, we change them all. We just go back and double everything. 2, 15, 10, and 10. And we did this in notes. If you were absent, make sure you're getting help on the CHO reactions, because those are just a little bit different to balance. Flip over to page 7, please. You're doing 2 things on page 7. First it says, A, classify the following reactions. S, D, SR, DR, or C. This is what we were doing on page 5. And then balance, and to receive credit, you need to show work. Okay. I know some of the other teachers really like this. Nonmetals, metals, hydrogen, then oxygen. That's a good rule of thumb. I usually tell my students to balance from the top down, unless it's a CHO reaction. Otherwise, you're totally fine to do that as well. So let's look at A, what kinds of reactions. What's happening in this reaction is that bromine and phosphates are switching spots, right? So they're replacing each other, for sure. It's going to be some kind of replacement. And no one's single. There's no single element. Sodium bromide, this is phosphoric acid or hydrophosphorus acid, I can't remember. Anyways, it's an acid. So that is 2 doubles. So it's a double replacement, 2 compounds. Same thing here on this one. You'll notice that hydroxide and sulfate are switching spots. I also went back and added parentheses here if you were struggling with that. That's another double replacement. So on number 3, which we're going to balance here together, magnesium and iron are switching spots. They are replacing each other, but magnesium is single before, and afterwards iron is single after. So it's a single replacement. CHO reactions are combustion reactions. And remember, combustion reactions get balanced just a little bit differently. Okay. So let's look at this one we got started. Okay, it says magnesium 1 and 1 before, 2 on the reactant side, 1 after, 3 on the reactant side, 1 on the product side. So I'm going to balance from the top down and leave oxygen for the end. Magnesiums are already balanced. To balance my iron, I'm going to say times 2 equals 2 on my product side, just like that. And putting a 2 there doesn't change anything else, it just changes the iron. To get 3 oxygen, I need to balance magnesium oxide, like this, because that gives me 3 times 1, 3 oxygen. It also gives me 3 times 1, 3 magnesium. So even though I had to balance magnesium, I now need to rebalance magnesium, which happens by multiplying it by 3. And then I have 3 and 3 for magnesiums, 2 and 2 for irons, 3 and 3 for oxygens. So I can come back and make that one a 1. So it is 3 to 1 to 2 to 3. Remember, you're not getting any credit if you're not showing work on these. Okay, let's look at number 5 as the last one for the video. We've got lead and potassium replacing each other. So potassium replaces lead here, and it's potassium sulfate. So it's a replacement, and you have a single. Potassium single before the reaction, lead is single after. So that would be single replacement reaction. I already counted the atoms before. So my leads are balanced, my sulfates are balanced, my potassiums are the only thing not balanced yet. So I can say times 2 equals 2 by putting that there. And, ooh, that's a nice one. Look, that doesn't change anything else. So 1 and 1, 1 and 1, 2 and 2. We're done. 1, 2, to 1, to 1. Okay. It's a lot of the same on page 8, so keep working on that. Good job, y'all.